All right, PreCal, today we're going to be talking about arithmetic sequences. An arithmetic sequence, AN, is a sequence in which the difference between successive or consecutive terms is called the common difference. Denoted as D, is often of the form A sub 1, A sub 1 plus D, A sub 1 plus 2D, etc., etc. Okay, so what does this mean? Well, this means if we have a sequence, let's say we got 1, 3, 5. So we got odd numbers, right, starting with 1. Okay, what are we really saying here? We're really saying 1 plus 2, comma, 1 plus 2 times 2, right? So essentially what it is, and this is sometimes we see this in other classes, where if it's n plus 2, and then n plus 4, but 4 is really 2 times 2. So the next one would be n plus 6, so this would be 2, n plus 2 times 3. Okay. This one written out would be 2 times 3. But essentially what it is, what this deal of plus d and plus 2d is that every time you jump, right, you're adding d. In this case, d being 2, the difference. Okay, so that's what's occurring in an arithmetic sequence. We also have the recursive form. The recursive form of arithmetic sequence is a sub n equals a sub n minus 1 plus d for some constant d and all n greater than or equal to 2. The number d is the common difference. So what this is saying, you're doing the same thing. So I would give you, let's say I say solve for a2, and I give you a1 is 1 and d is 2. So you go 1 plus 2 is 3. 3 plus 2 is 5, so on and so forth. So you're just essentially substituting in the values. So again, let me rewrite this. So given an equals a sub n minus 1 plus d, if I tell you a1 is 1 and d is 2, then we can say 1 plus, well, let me write it out formally. It would be a2 equals a1 plus d, or maybe even more formally, a2 minus 1, because if n is 2, right, this is 2 minus 1, so a sub 2 equals a sub 1 plus d, and if d is a is 1 and d is 2, you get a2 to be 3. And then we substitute back in, so then it's going to be a3 equals a2 plus 1, a2 is 3, so 3 plus 1 is 4. I'm sorry, 3, I said 2, my bad. 3 plus 2 is 5, etc., etc. Okay, all this is saying is you take what you have initially, you do the math, and it gives you the next value, and then you plug that next value in, do the math, you get your next one, and then repeat. Okay, and if we think about this even more generally, right? What is this? What are we really doing? If we're adding the same thing, d is the what? Well, these are linear. This is like a linear equation, right? Every jump is always the same. The jump is the slope. So when the slope is plus d. That's something to keep in mind as we progress through this. But let's look at the next one. If un is an arithmetic sequence, u sub 1 equals 2.5 and u sub 2 is 6, find the first two terms. So we're saying in the sequence we got 2.5, comma 6, comma I don't know what, but we're saying it's linear. So if we know it's, I'm going to interchange these words, but it's not just linear. We're looking for the common difference. If it's arithmetic, then this difference is literally the difference between 6 and 2.5, which is 3.5. So we got d to be 3.5. All right. And then if we look at the next one, it says find the recursive sequence. So this is easy. It's a sub n equals a sub n minus 1 plus d. So it's a sub n minus 1 plus, well, what do we get d to be? 3.5. So this is my recursive function, right? And we'd say, so what we would do if we wanted to play with this, we'd take 2.5 and we'd plug it in here. Now, I used A. I guess since it's technically U, we should write it like this. Potato, potato. Not a big deal, but this would be our function. Okay. Give the first 6 terms of the sequence. So look, we know the first one is 2.5, the second one is 6, and the next one is 6. To find the next one, we're just going to, so all we're doing here is we're just adding 3.5, right? So you go 6 plus 3.5 is 9.5. 9.5 plus 3.5 is going to be 13. 13 plus 3.5 is 16.5. 16.5 plus 3.5 is going to be 20. What do I have? This is U1, U2, U sub 3, U sub 4, U sub 5, U sub 6. I'm good. Okay. And I always like doing this. I feel like, believe it or not, we make lots of mistakes when we count. So I always like writing them out if it's not too, if the number isn't too large. All right. And then it says plot it. Okay, so I'm going to do this. I'm going to take this. Let me see if I can move this. Let's take these and bring them down here. So now I can see what I'm plotting. Okay, so if I plot it, we got 1, 2, 3, 4, 5, 6. Let's see if I can write it in. 1, 2, 3, 4, 5, 6. Let's say 2.5 is here, 6 is up here, 9.5 is here, 13, 16.5, and put 20. This graph is definitely not big enough. But what you will see, and the particulars are not that important here, what we should see is the graph, and this should be obvious, is going to be linear, right? Because you're basically jumping, for every one jump, you're jumping 3.5. It's in essence what's going on here. So they wanted just to draw a graph, kind of jump to the punchline of the joke. They wanted us to illustrate this, to self-illustrate that the graph is linear, because so an arithmetic sequence is linear, and that's what this is saying. So this is saying the explicit form of the arithmetic sequence is written in the terms of the first term of the sequence for every n greater than or equal to 1, and d the common difference. So then they jump to a1, a sub 1, and a sub n. Same thing as un and u1. This is your first term. This represents the number of terms, the term itself. So like a1, a2, a3, a4, like 1, 2, 3, 4. D is the difference between the two terms, and a sub n is the nth term. You can think of it as like the next term, the term you're looking for. So just to be clear here, this is the first value. So like in this particular problem, this would be 2.5. N would be what you're looking for. So let's say we're looking for the 6th term, so it would be 6. D would be the difference, which is the jump, which is 3.5. And a sub n would be what that term is, which in this case would be 20. So if we plugged into this formula, that would generate this. So let's look at this example. So the formula again is a sub n equals a1 plus n minus 1 d. And it says, I'm not going to sketch it. It's going to be a line. Okay. The first term is -3. So that means a1 is -3. It's my steak sauce. Plus the common difference is 4. Now, yeah, and so we're going to sketch. So the sequence becomes a sub n equals -3 plus n minus 1 times 4. Just rewrote the same thing. Some people in some textbooks, they'll want you to clean it up. We can do that pretty easily. So a sub n is equal to 4n minus 7. So what this shows you is that, again, what I've been stressing, which is this is linear. So basically, right, this is saying that we're at negative. So here I am saying, I'm not going to sketch this, and then I go ahead and sketch it. It's just a linear line with a slope of 4, right? That's what each of these points would be. Now, technically, the thing about this is when I'm drawing this, I'm drawing a straight line. Really, it's just the points, right? And I don't know exactly what the points are. I'm just drawing random points. But the graph is a linear line. And so what I want to stress here is that this is y equals mx plus b. This is y equals, the a1 is b, the x is the n minus 1, and the d is the m. Think of it in that sense, and that's why it's just linear. So you're really just going back to algebra 1. All right, example 3. Find the sum of the first 6 terms of a sequence un equals -1 plus 2n. Okay, so let's just play with this a little bit. We got u1 equals -1 plus 2 times 1, which would give me 1. U sub n2, would be -1 plus 2 times 2. 4 minus 1 is 3. U sub 3 plus 2 times 3. 6 minus 1 is 5. U sub 5, 1 plus 2 times 4. 4 is 8 minus 1, which is 7. So we're seeing what the pattern is. I have to do, what, 6 of them? The pattern is what? I hope everyone sees this. The pattern is it's the odds. These are the odd numbers, right? Starting with 1, 1, 3, 5, 7, 9. Okay. And so it says find the sum. So if I find the sum, I'm just adding them up. 1 plus 3 plus 5 plus 7 plus 9, which is going to give me what? This is 4. This is 12. And this is 9. And so if I put these together, that's 16 plus 9, which is 25. Okay. All right. Now, there is something else that we can talk about in regard to this, but I'm going to keep it a little more interesting. So there is I'm not going to use that same formula. I'm going to use a different one. Okay, let me make this. Okay. Well, let me see here. Yes, I can make it a little bigger. There we go. Okay. So what do I want to talk about here? So there is this equation, and this doesn't come from, well, actually, let me back it up here. So when I look at, where's that equation? Where did it go? Nope, nope, nope. Where? Well, I've lost it. Ah, here we go. Okay, so when we looked at this equation, I said, is really just y equals mx plus b, right? So this derivation comes from the fact that people who studied arithmetic sequences came to the realization that they're like, hey, look, it's just a linear equation. So they just reformatted it, but they're using the idea of a linear equation behind this, okay? When we go to the summation, there is a thought entailed in this, okay? And there's a great little story in math about this, which is a famous mathematician named Galois when he was in school, he was asked to add up the numbers from 1 plus 2 plus 3 plus 4 all the way up to 100, okay? So his teacher was having one of those days, we all have one of those days, where they didn't want to work too hard, so they just said, you know what, I'm just going to create a lesson off the top of my head. I'm just going to ask the kids to practice adding. So they're adding the numbers from 1 to 100. She figured, oh, these are little kids. It's going to take them all day to do this. This will be enough for the day to give them for work. Well, Galois spat out the answer in a couple of seconds. And the question is how did he do it? Well, I'm going to use the numbers 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. So I'm going to have the numbers from 1 to 10. No, I was not going to write out 1 to 100. Okay. And what Galois saw was something very interesting. What he noticed is that 1 in plus 10 is 11, 2 plus 9 is 11, 3 plus 8 is 11. These are all 11, right? And I'm going to take this idea a little one step further. They have to be 11 apart. Because if this sum is 11, let's start with the innermost. What did you do with this term to get to 4? You subtracted 1 from 5. What did you do with 6 to get to 7? You added 1. So when we add them, 4 plus 7, what is 4 plus 7? 4 plus 7 is really 5 plus 6. It's just we added a negative 1 and we added a 1 here. So these are the negative 1 and the plus 1 are going to go away. And if you jump again, right, now the jump is 2. So you subtracted 2 from 5, you added 2 to 8, and they cancel out. So that's why this effect is happening. There's because these are all equally spaced, you're always jumping the same amount away, whether you're going backwards and forwards. So Galois saw this and said, hey, all I got to do is figure out what 5 plus 6 is, or really, you could even just do 1 and 10, and then count up the number of pairs you have. So we have 3, 4, 5. We have 5 pairs. So that would be 5 plus 11. This would be 55. In his example, he was 1 to 100. So he added up 1 and 100. And he said, how many pairs you have? Well, if you're going from 1 to 100, that's 100 terms. The pairs would be 100 divided by 2. I feel like eating an apple. Okay, which gives you 50-50. And that's the answer. So kind of a cool little thing here. And that's what this formula is really saying. This formula is essentially saying n is the number of terms, right? In Galois' case, it's 100 terms divided by 2. And then you add the first term and the last term. Okay, that's it. All right. Now, the other thing we can do is if you substitute in the sequence formula into the series formula, you can get a formula, this formula here, which is essentially using both at the same time. Okay, I'm not actually a particular fan of this. What I usually do is I just write the sequence formula, and then I write the series formula. And according to the problem, I substitute what I know and use that to figure out what I don't know. I don't like to have one giant formula. I feel it's better to partition it because I'm focusing on the more I have inside something, the more likely it is I make a silly mistake. So I like to keep it as simple as possible, and then once I get a value, then I can just substitute that value in. But it's to each their own. There really is no preference to this. Preference is just what you think is best. Okay, so let's do an example. Use the calculator display. We don't need no calculator. To the first 7 terms of the sequence of blah blah blah, and compute the sum of this. Okay, I'm not gonna worry about listing the first. Well, you know what? Let's go ahead and do it. So un equals -5 plus 6n. And if we want to write out the first, then we plug in 1. U sub 1 equals -5 plus 6 times 1, which would give me 1. U2 would be -5 plus 6 times 2, which would be 12 minus 5, which is 7. Well, we know what it is, right? The jump every single time is plus 6. So U3 is -5 plus 6 times 3, right? Because if you're going 6 times 2, the next one's 6 times 2, that's just plus another 6. So whether you do 18 minus 5 or 7 plus 6, you're getting 13. So U4 is plus 6, so that's 19. U5 is plus 6, so 25, and u6 is plus 6, which is 31. And then the next question is, well, what's the sum from 1 to 100? Okay, so, well, I guess I should write 1, 7, 13, 19, 25, and 31. Well, if I want to figure out the sum from 1 to 100, well, I better figure out what the 100th term is, right? So now let's do it. -5 plus 6 times 100, which would be 600 minus 5, which is 595. The first term is 1. The last term is 595. Galois taught me take the first, take the last, add them together, divide by the pairs, and we're good to go. By the way, this is the same thing as me just saying substituting n over 2 times a1 plus an. I just think Galois' story, our brains are functioned to work based off of stories, not really based off of equations. So n is 100, a1 is 1, an is 595. If you want to plug in, you can, but I like to think like a human, not like a robot or computer. And so we're doing 50 times 596. And we tack on the 0. There we go. And there's my answer. Okay, hopefully that makes sense. Let's jump to the next one. Example 5. Find the 38th term of the arithmetic sequence whose first 3 terms are 15, 10, and 5. Okay, so if they're 15, 10, and 5, we know the difference here is -5. Now notice it's dropping by 5, right? So it's -5. So if the formula is a sub n equals a1 plus n minus 1d, we know the difference is -5. We're looking for the 38th term. We know the first term is 15. Rock and roll. So this is 15 plus 37 times -5. This is 35, 15, 18, 15 minus 185. So 185 minus 15 is -170. And just to be, I think everybody does this. I tend to like to write a sub n, but it's actually a sub 38. Technically, I'm not going to take points off if you put a sub n. I'm not going to worry about that, but technically it should be a 38. Okay, easy enough. So identify the appropriate formula and apply. Okay, and if you don't know, write both formulas out and just play with it. See where you go with it. Okay, let's see the next one. 6. If u sub n is an arithmetic sequence with u5 is 22 and u11 is 65, find u sub 1. Okay, so we got, I'm going to visualize this, u sub 1, u sub 2, u sub 3. We're going to go to 5, right? 4, 5, and actually we got to go to 11. 6, 7. I'm starting to want to write u sub whatever as the value. U8. What did you eat? Meh, meh. U9. Or am I saying you know in German? Meh, meh. U10. Got no bad pun there. U11. Okay. I feel like I'm saying your age. Hey, U5? U11? Okay. All right. Thoughts while writing. Okay, so what do we need to figure out? Well, let's figure out what the jump is, right? So what did I do from 5 to 11? Well, I jumped 1, 2, 3, 4, 5, 6, right? Now you might be thinking to yourself, well, Mr. Anderson, why did you count? You could have just said 11 minus 5 is 6, and that's true, okay? Now let's think about what this really means. This is 22 plus d, 22 plus 2d, 22 plus 3d, 22 plus 4d, 22 plus 5d, So this one would be 22 plus 6d, right? The jump, we jumped 6 times, and each jump is the difference, right? So that would be 6d. So, oh, look at that. We got an equation here. We can say 64 equals 22 plus 6d. And so now just subtract 22 from both sides. So 42 equals 6d. Word on the street is 6 times 7 is 72. 42, wow, 42. So d is 42. Okay, well, now I know what d is, but I need to figure out, well, it's two colors too close. Let's go orange. What do we have to jump, right, to get to 5? Well, you have to jump 5 minus 1, right? This, by the way, is it's n minus 1, right? So in the formula, it's not really n minus 1, right? These are, like, if you're going from the 5th to the 11th, this would be 11 and this would be 5. It's just when we start, we're at 1, so that's why this is 1. Okay, so now we can say, I guess I should write the formula. an equals a1 plus n minus 1 d. I know the first term is, actually, I don't know what the first term, so we'll call it, I always want to call it a, and here they're calling it u. Grr. Okay, u1 is still u1, because I don't know what that is. We're looking for the 5th term. The difference, we figured out the difference to be 7, and we're looking for the 5th term, which is 22. I'm sorry, we know the 5th term is 22. So we just solved. So u1 plus 4 times 7 equals 22. I always love it when it's like this. So 22 minus 28 is u1. Right, this is 28 subtracted over. Negative 6 is u sub 1. Boom. So there we go. And the question is asking, find u sub 1, got it, a recursive formula. Recursive formulas are easy because it's just un equals u sub n minus 1 plus d, because it's just what you're adding. So this is just going to be u sub n minus 1 plus negative 6. I'm sorry, 7, right? Because d is 7, and that's going to equal to u. So yeah. And this format is actually more functional. Some of you might be thinking, well, why not just plug in the first term? Because I might not be starting from the first term. And if I want to write it as the explicit form, right, it's going to be u. This is the recursive. We'll write R for recursive. So un equals u. Well, I guess I'll just write u1 as what u1 is. What is u1? u1 is negative 6 plus n minus 1 times d, which is 7. I like it like this. I think it's more functional like this, but we can always also clean it up. So 7n. For whatever reason, we like to write the n front. There you go. So there we got it. And that is it. Okay. And that is actually it. We're done. Okay. So I hope that this makes sense. At the end of the day, you're basically doing linear equations all over again. So I hope this makes sense. And if not, reach out to me. Otherwise, I will find you in the next math video. Bye-bye.